Okay, before we look at section 3.2 in Algebra 2, we're going to do a review of properties of exponents. So let's go through all of these properties first. So we're going to let A and B be real numbers, so no imaginary, no complex, and N and M are integers, okay? So the product of powers says that if I have A to the M times A to the N, so they have the same base but different exponents, I simply add my exponents. So an example of that, I could look at x squared times x to the fifth would be x to the 2 plus 5 seventh, okay? Power of a power, I have one base, a to the m, all of that is raised to an exponent n, so I multiply my exponents, power of power. So here, if I had x squared, all of that to the fifth power, I would multiply 2 times 5 and get x to the 10th. Power of a product, if I have two things inside the parentheses being multiplied together and they're being raised to the same power, I can just separate them. So let's say I have x, y, quantity squared. This would be x squared and y squared. Negative exponents. We are not allowed any negative exponents. So if I have a negative exponent, then I move it to the denominator to make it positive. If it starts out in the denominator, I move it to the numerator to make it positive. So if I have x to the negative 2 power, that is going to be the same thing as 1 over x squared. If I had 1 over x to the negative 3 power, I move it back up and make it x cubed. Zero exponents. Anything to the 0 power is equal to 1 as long as a does not equal 0. So I could have 752 to the 0 power, it equals 1. Quotient of powers, a to the m divided by a to the n. I subtract my exponents as long as a is not equal to 0. So again, if I have the same base, so let's say I have x to the 10th divided by x squared. So I subtract my exponents, 10 minus 2 gives me x to the 8th. And then power of a quotient. So if I have two things being divided and they're both being raised to the same power, again, I could separate them. So that's like saying x divided by y, quantity cubed. It's the same thing as saying x cubed divided by y cubed. All of the examples that I gave to you dealt with variables, but they work the exact same if I just had numbers instead of variables. So let's look at this. Evaluate the power. So 3 cubed, that means 3 times 3 times 3, which is 27. 10 to the negative 2 power means 1 over 10 squared, because I have to make it positive. 10 squared is 100, so 1 over 100. 40 to the 0 power, that's 1. Anything to the 0 power is 1. 7 squared is 7 times 7, 49. 2 to the negative 3 power, no negative exponents allowed, so to make it positive, I move it to the denominator, so it's 1 over 2 cubed. But then I can work that out. 2 cubed means 2 times 2 times 2, which is 8, so 1/8. Evaluate the expression. Remember, anytime we see the word evaluate, that means you're going to have a number as an answer. Okay, evaluate means numbers. So 4 squared, quantity cubed. So remember that power to a power, I multiply my exponent. So 2 times 3 is 6. I don't leave it like that because I can actually evaluate that. So 4 to the 6th power is 4,096. Negative 8 times negative 8 to the 3rd power. Remember, this is like negative 8 to the 1st times negative 8 to the 3rd. So that's going to be negative 8 to the, I add my exponents, 1 plus 3 to the 4th power. It's very important if you're doing this in your calculator that you put parentheses around your negative, right? Or else your calculator will lie to you. It will give you the wrong number. So negative 8 to the 4th, that means negative 8 times negative 8 times negative 8 times negative 8. So anytime I have a negative being raised to an even exponent, my answer will always be positive. This is positive 4,096. 4 squared to the negative 1, okay, power to a power. I multiply my exponents. That becomes 4 to the negative 2, but we can't have negative exponents, so I move it to the denominator. It becomes 1 over 4 squared. I can evaluate that, 1 over 16. And we always leave these as fractions. We don't ever change those to decimals. All right, the next one, 2/9. All of that quantity cubed, so I can separate this. This is 2 cubed over 9 cubed, but then I can work that out. 2 cubed is 8. 9 cubed is 729. They don't have anything in common that I can reduce by, so that is my answer. 6 times 10 to the negative fourth divided by 9 times 10 to the seventh. I can do the 6 divided by 9 and then times, I have a negative 4 exponent. It needs to move down to the bottom, and then I would add them. So that times 10 to the 7 plus 4 becomes 11. Now the 6 and the 9, I can reduce that. They both have a 3 in common, so that becomes 2 over 3 times 10 to the 11th power. Simplify. Okay, so simplify does not say evaluate. Simplify means reduce as much as possible. X to the negative 6, x to the 5th, x cubed. So I add all of my exponents, right, because they all have the same base, x. Negative 6 plus 5 is negative 1. Negative 1 plus 3 is 2. So x squared is my answer. Here I want to multiply. The only number I have is 7, so 7. Y squared times y to the negative 4th. So I add my exponents. So I get 2 plus negative 4, negative 2. Z, 5 plus negative 1, 4. I could not leave my answer like this because I have a negative exponent. So everything that's positive exponent stays up top. So 7z to the 4th divided by y squared goes to the bottom to become a positive exponent. 16n to the 4th into the negative 5th divided by 2 n to the negative 5th. So first 16 divided by 8, or 16 divided by 2 gets me an 8. I have an m to the 4th. That's the only m I have, so it stays m to the 4th. N to the negative 5th and n to the negative 5th, they actually both cancel each other out. Anything divided by itself is 1. So my answer is just 8n to the 4th. X to the 4th, y to the negative 2, divided by x cubed, y to the 6, all of that cubed. I can go ahead and just raise everything to the 3rd power, do my power to powers, and then start simplifying. So remember, power to power, I multiply. So x to the 4th cubed, so 4 times 3 is 12. Y, negative 2 times 3, negative 6. Over x, 3 times 3, x to the 9th. Y, 6 times 3, 18. So now I have an x to 12 on top, x to the 9 on the bottom. I subtract 12 minus 9, leaves me x cubed. This y to the 6 really needs to come down here to be positive. So I've got x cubed on the top divided by y 18, y to the 6. I add my exponents. So 18 plus 6, y to the 24th. A to the 4th times b squared, I add my exponents, so 4 plus 2, b to the 6th. X to the negative 3, x to the 5th, I add my exponents, negative 3 plus 5, x squared. S to the 7th, all of that quantity squared, I multiply my exponents, so s to the 14th. Here I have to square everything inside, so 5 squared gets me 25, y squared. All right, 24, x to the 0, y to the negative 5th, x to the negative 6, y to the negative 12th. So I have a 24 and a 64. I see that they both have an 8 in common. So 8 goes into 24 3 times, 8 goes into 64 8 times. X to the 0 just turns to 1. X to the negative 6 needs to come up to the top to be positive. My y's, 12 needs to come to the top, 5 needs to go to the bottom to become positive. Now I can simplify the y's. So on top I have 3x to the 6th. On the bottom I still have my 8. So I subtract my exponents for the y's. So 12 minus 5 leaves me y to the 7th on top. 3x squared, y to the negative 2, all of that quantity squared, times 6x to the 5th, y to the negative 3. So first I need to do everything squared here. So 3 squared gets me 9. 2 times 2 is x to the 4th, y to the negative 4th. All of that times 6x to the 5th, y to the negative 3. So 9 times 6 gets me 54. Now I'm going to add my exponents. X to the 4th, x to the 5th gets me x to the 9th. Y to the negative 4th and the negative 3, so y to the negative 7th. I can't have a negative exponent in the answer, so I have 54x to the 5th divided by y to the 7th. The next one, 12x squared, y to the 7th, z to the negative 3, 52x squared, y to the negative 6, z to the 8th. Okay, so I have a 12 and a 52. The biggest number that they have in common is a 4. So 4 goes into 12 3 times. 4 goes into 52 13 times. X squared and x squared, they cancel each other out. I have a y to the negative 6 on the bottom, so y 7th, y to the 6 comes up top. My z to the 8th stays in the denominator. Z cubed goes down there with it to become positive. Now I'm going to combine everything I can. So on top I have 3, y 7 plus 6, y to the 13th. Over 13, z 8, z cubed, so 8 plus 3, z to the 11th. All right, the next one, 7 to the 0 power, k to the 4th, all of that to the negative 8. So 7 to the 0, that's really 1, right? So this becomes 1 to the negative 8th, k to the negative 32. 1 to the negative 8th is just 1. I move it to the denominator. I have 1 over 1 to the positive 8th, and then k 32nd. So 1 over k to the 32nd power. All right, let's review scientific notation. Remember scientific notation, a number in the form c times 10 to the n, where c has to be between 1 and 10, and n is an integer. So we're going to write in scientific notation. So this is where my decimal is. I need to move it between the 3 and the 2. So I know it's going to be 3.25 times 10. If I'm starting at the right and I go to the left, then it's a positive number, right? So how many decimals did I go? 1, 2, 3, 4, 5. So 10 to the 5th. I'm starting at the left and I'm moving to the right. It's a negative exponent, so I know that I need to move between 2 and the 5. So 2.56 times 10 to the negative 1, 2, 3, 4, 5. 4.2 times 10 cubed times 4.5 times 10 to the 6. So I multiply my numbers, 4.2 times 1.5, and then I have times 10. I add my exponents, 3 plus 6, 9. So 4.2 times 1.5 is 6.3 times 10 to the 9th. Same thing with the division. I'll divide 8.1 divided by 5.4, and then times 10, subtract my exponents. 12 minus 9 gives me 3. So 8.1 divided by 5.4 gives me 1.5 times 10 cubed. So that's just a review from Algebra 1, Properties of Exponents and Scientific Notation. This will help us for the rest of this chapter, but especially once we start section 3.2 tomorrow. So your homework is going to be very similar to all of this, working with these properties.